So, hello everyone. Welcome to Tuesdays with Trailblazers, brought to you by TechEdge AI, the video podcast where we bring you the latest trends and insights in AI and technology. I am Bhakti, your host. Today, we are covering Qumulo. Qumulo's mission is to simplify unstructured data management for workloads at exabyte scale in any location, providing a single software solution to cost effectively store, manage, and curate the data at the edge in core data centers or in the cloud. And to tell us more about this journey, we will speak with Ryan Farris, VP of Product and Marketing, who's well versed in multiple product and engineering disciplines. Hello, Ryan. How are you doing today?
Bhakti, I'm doing great. Thanks so much for having me on your program.
Thank you so much for joining us. So, reflecting on your 2 decades career in product management and marketing, what significant industry changes have you observed? How do you prioritize customer needs in your approach to product development?
Yeah, I think in the last 2 decades, of course, lots of things have changed. Things change, I think, on an average around 5 years. The whole world is disrupted, new products come out, the industry just completely changes. With respect to storage, I kind of cut my teeth in the technology industry at Isilon. Isilon was acquired by EMC, and then that was eventually acquired by Dell. But since that time, it was all about scale out storage. That was kind of the disruptive thing at the time, servicing a large need for expandable and expansible, scalable storage on premises. And since then, a lot of this world has kind of been disrupted into hybrid infrastructure solutions. So now we see kind of solutions that require seamless data movement from on-premises into the cloud. Scalability issues are abound. They're much different today than they were, 15 years ago, where everybody around the globe, no matter from what region, need access to the same kinds of data. And certainly public clouds and features within hyperscalers have accelerated that expectation from users. So that's one of the biggest changes.
So, how do you manage both strategic planning and day-to-day operations when Qumulo is growing so quickly? Can you give us an example of a product you developed that started with customer needs and led to major growth?
Yeah, that's a great question. I spent about a half a decade at Amazon, and one of the things that they hammer into you was starting from the customer and working backwards, right? One of the leadership principles at Amazon is customer obsession. Qumulo has the same thing. Qumulo calls customers its magnetic field, which is very similar to the leadership principle in Amazon. And so it's really important for us to be highly attuned to customers' needs as they evolve and as the industry changes as well. So one of the things that we did about a year and a half ago, maybe 2 years ago now, it's about a year and a half ago, we wanted to embark on this major feature that allowed customers to access data no matter where it resides. This feature ended up being called global namespace. But to kind of rally back around to the question, what we did is we gathered inputs from a lot of media and entertainment customers that were asking for similar things in very different ways. And the problem that they were trying to solve was that, hey, I have a studio in Montreal and a studio in New York and a studio in London, and I want to be able to seamlessly share data between those organizations such that when my artists come online and start to do work and animation and work on the same sort of data set repositories, that they would be able to do that seamlessly and without a lot of infrastructure pain. And so the deep dives were about 2 days worth of kind of this think tank, or like this way to gather a bunch of inputs from industry architects in media and entertainment. And we kind of looped back with that same audience a couple months later to ensure that we're vetting the requirements and that our basic bones of the architecture for the feature that we wanted to build was directionally correct. That's fairly similar to what Amazon does as well. Takes an array of requirements and proposes, hey, this is the thing that I want to build, and these are the problems that I'm trying to solve. And we fast forward to about a year and a half later. Now we're in a private preview of that feature, and we have the same customers that were providing inputs on this feature actually kicking the tires and willing to be publicly referenceable customers when we GA this thing. That's one example. There are several others, but that's one example, Bhakti.
That's a really magnetic solution. I mean, that makes sense. So now AI is taking a center stage. How do next generation cloud storage solutions fuel these powerful applications?
Yeah. Okay. So this is a good question. There's a lot to say here. There's kind of a lot to unpack. Let's talk about AI and sort of its role in the cloud, in the public cloud. And that's kind of the place where Qumulo customers are largely pushing us when it comes to AI. And so the problem statement, or some of the things that I should touch on, is that if you have a bunch of GPUs that you've now rented by the hour in the cloud, just kind of how cloud economic works, either you can have reserved instances for GPUs, or you can pay, as a pay-go and hourly model. And so if you are purchasing or renting GPUs, you want to keep them as busy as you possibly can, right? And so cloud native object stores are really critical here. And it's kind of like nutrient rich soil in a garden, right? So it provides all these essential elements for an AI model to develop and grow. And the challenge is that if you have, say, a couple petabytes in S3 and in AWS or in Azure Blob, getting at that data for file dependent applications is a challenge, because you have to pull large amounts of data into kind of these temporal file caches. So imagine if you have a couple petabytes and you want access to a few hundred terabytes of that data. It's difficult to kind of have this landing or proving ground such that training models can and high computational activity from those GPUs can actually start to perform work. Okay, so what we do is that for Azure native Qumulo, we solve that general problem. And one of our advantages is that we're a solution that provides performance elasticity in the cloud. And that's a fundamental that has existed in the public cloud since it started. You would kind of expect performance elasticity from any service. But for file storage, it's actually quite novel. And if you look at kind of some of the other file service offerings in Azure or AWS for that matter, they tend to be fixed volumes. So you might pay a couple $100 per terabyte per month for this fixed volume that cannot kind of grow elastically and offer the performance that you need from this large set of GPUs. And so for Azure native Qumulo, that is a product that we launched about a year ago. What we do is that we're really efficient in pulling data from the object layer into high computation or high performance NVMe caches, so that we can feed all of that data to hungry GPUs and keep them busy and more efficient. And sort of as a proof point for that, so one of the things that we did recently is that we ran a benchmark called AI Image. And AI Image is from the Spec Storage series or suite of benchmarks. And what they've done is that they've synthesized in this benchmark kind of common I/O patterns from AI workloads. And this includes large ingest operations that require a bunch of throughput so that you can keep your GPUs busy. They're synthesizing model training based on kind of I/O patterns that are taken from the ubiquitous TensorFlow framework. It's a common ML framework that's been around for a long time. And then they also include model checkpointing. So if you're in the middle of some very large job run by, say, 100 GPUs and that job fails, then your checkpoint can allow you to pick up where you left off. So this benchmark synthesizes all of those things and does a really good job of it too. So we ran this benchmark in Azure native Qumulo to see how well we could perform in a relevant benchmark for AI. And we the first time we ran it, we were delighted and kind of surprised around how fast it was. And we ran it several dozen times and got repeatable high performance results. And so we published that benchmark into Spec Storage. If you go to Spec Storage, specstorage.org, you can see our performance benchmark. And it scaled from 0 to 700 jobs and gave really even latency throughout the entire session. So the entire benchmark lasted about 4 to 5 hours. And one other thing that is notable for the benchmark is that the cost of running it and the cost of scaling from 0 to 700 jobs was about $400. And the reason why that's significant is that you don't have to pay for anything else after the job is done, that you're only paying for the performance elasticity required for the length of the job. So AI workloads, as you can imagine, are pretty bursty in nature. Like they're not 24/7 workloads. Either initial training or ongoing AI training is going to require peaks and troughs, right? And so the problem, or one of the problems that we're solving, is that if a customer wants to use, say, 100 GPUs, they have something very large and computationally intensive to get through. it's either initial model training or they've discovered a bunch of new data that needs to be trained. Well, the length of the job, the entire length of the job is only what you pay for with A&Q with regard to throughput needed for that job. So there's another thing that you can read about. We also issued a blog post on Qumulo.com that kind of talks about the technical details therein as well.
That's amazing. I mean, little much, very impressive. So now that what you just mentioned about the cloud thing, so there's a lot of buzz around the word cloud native. Can you explain that, what that means in context to of a software development and infrastructure?
Yeah, when we talk about cloud native architecture, and really what we're talking about when we kind of describe our architecture to our prospects and our existing customers, is it usually kind of starts out with, hey, I want to move more file data to the cloud. We already have a bunch of object data. I want POSIX compliant file systems that are cost effective, right? And I don't want to pay $200 per terabyte per month, which is what NetApp might charge me, or even more than that. So we usually kind of pivot the conversation to what our cloud native architecture consists of. And so as a service, we call that, again, it's called Azure Native Qumulo. We're building kind of the equivalent in AWS, which has not gone GA yet. But for cloud native Qumulo or Azure Native Qumulo, the architecture is built on the sort of the primitive infrastructure that is offered by Azure. These building blocks that Azure that we've co-built with their engineering team, and so we've disaggregated the compute layer and the data at rest layer. And what we do is that if a customer wants to push, say, a petabyte of data from on-premises into the cloud, all of that data is eventually going to be stored and retrieved from the object layer. But since our compute is disaggregated from object, what we're doing is that any SMB or Windows client, or if it's a Linux client, it's fetching data over NFS, we're prefetching data from the object layer and pulling it into NVMe cache. And so kind of the meta point is that we've re-architected file storage for the cloud to make it super efficient, really performant, elastic, and finally cost effective. So one of the major side benefits of this architecture is that it's truly kind of cost disruptive. And if you compare it to an array of competitors, we wind up about $37 per terabyte per month as an entry point. And that's to give you a contrast point, that's compared to around $150 per terabyte per month for the average data footprint offered by either Azure Files or Azure NetApp Files, or some of the file services that sit under the FSX, the AWS FSX umbrella. So super cost competitive without having to sacrifice performance or data services or things like that. And that's kind of how we frame cloud native architecture.
Sounds like a game changer for all the SMBs and the startups. So on the same side, I want to understand how what tips do you have for the newer startups or SMB organization when it comes to data migration to the cloud? Because it's quite daunting. So how do you prioritize which data to move first?
Yeah, that's a great question. It is pretty daunting, especially if you have more than a petabyte, or if your data footprint is sizable. Automatically, you're looking at the cost to move that data, or the cost to hybridize the data. And usually that is the shape of the conversation, is that I don't want to lift everything and move it to the cloud. I, at the very least, want to operate in a hybrid model, because there are some instances where keeping your data on-prem makes a lot of sense. So to answer the question, I think it comes largely in two different flavors. Either it's application by application. So you can just look at the binding of the application and all of the data that is dependent on that application and make the decision based on the requirements of your app. That's one way to do it. That can be pretty limiting, and it can be potentially painful. But one of the benefits of Azure Native Qumulo is that you can lift and shift your application without having to worry about rewriting the application to speak S3 or object semantics, right? So you can do it app by app. Another way to do it, especially if you have a very large data footprint, is that you could do it based on cold data or cool data. So if you have a data repository that you're convicted that this is cold data, it's not going to be touched, it hasn't been touched for a year or more. That's a pretty good way of saying, I'm going to take that cold data, especially if it's kind of cordoned off or segmented from applications, and I'm just going to move that to the cloud. And that way I can retrieve it anytime I want. I kind of don't have to pay for the ongoing burden of infrastructure refreshes, and it's super cost competitive. Month after month or quarter after quarter, you look at the cost of storing cold data in the cloud, it just keeps getting better and better and more cost competitive compared to on-prem. For Azure native Qumulo, we also offer a cold tier as well. And the cold tier is comparable to Azure Cold Blob. So that's another thing that you could do to maintain application compatibility while moving large segments from on-prem into the cloud without breaking your application. So I think there's a lot of ways to do this. Another way to do this is to use a data mover, a data orchestration, like a software package like Atempo, Comprise, Rubrik. There are several of them on the market that we work with. And what that does is that it'll kind of it gives you the flexibility of saying, hey, I'm just gonna let Comprise or Atempo or Rubrik worry about the data orchestration and the placement of this data without having to really change anything on your application. So that's another way of kind of pushing the intelligence of what to move and to kind of create these rule-based policies that if your data is aged for 60 days or more, then I'm automatically going to move that to a different location in the cloud. It's another way to do it.
Really excellent advice. Very insightful. So looking ahead, where do you see AI industry evolving in today's landscape?
Yeah, I think more and more of it will move from on-premises to the cloud. I think one of the reasons why we have that view is that for on-premises, NVIDIA has, of course, cornered the market. Their shares, if you're an early investor, congratulations to you. But NVIDIA is just wildly popular, right? So if you're looking at file storage coupled with NVIDIA GPUs on premises, that is a costly endeavor. And you might have to look at and kind of be faced with this very large capital outlay to have direct attached storage or something that gives you speeds and feeds and a performance profile that you might not actually need. So we think cloud and AI training and bootstrapping models is much more relevant and much more likely to happen, especially for entrance into AI in the public cloud. So I think both more data movement to the public cloud, especially file data, and hybridized environments that automatically move data, smaller footprints of data that need to be trained in the public cloud. Moving that in kind of these burst scenarios where I have 50 terabytes of data that I identified as data that I need for my models, and that moves up to the cloud. You do your computation, you get a result, and then you send that result and dispatch it to the application that needs it. That's a model that's much more likely to kind of happen more and more as we unfold this big thing that we call the AI revolution.
And there's a lot of learning today that we had. And I really enjoyed you today on our podcast, Tuesdays with Trailblazers. And thank you all of you for joining us. If you really enjoyed this episode, please like, share, and subscribe. And don't forget to leave a review. Until next time, stay tuned with TechEdge AI for more insights into all things AI and technology. Till we meet again, signing off, your host Bhakti. Thank you.